Okay guys, here we are in problem number 6. Again, use my blue ink. I'm on free response number 1. So I'm going to be doing an ice problem. It's the ionization of HOCl. So HOCl ionizes in water to produce H plus and OCl minus. These are all going to be aqueous. Aqueous ICE. I can write K, let's see, it's going to be Ka because this is an acid. Ka equals OCl minus multiplied by H plus all over HOCl. Okay, now let's start the problem, baby. Here we go. Alright, they gave me Ka. So we know that this is equal to 3.2 times 10 to the minus 8. So if they give you Ka, you're going to be using Ka. You're going to be using it to find X. So there's the answer to A right there. We got that. There's the answer to B. We got that. Calculate the pH of a 0.75 molar solution of HOCl. pH equals negative log of the H plus concentration. So we need H plus. There's H plus. If they had OH, we would need to go from pH to POH. They do not. So we're looking for that. The negative log of what's inside that box is going to be our answer. They do say that we're starting with 0.75 molar HOCl. 0.175 molar HOCl. 0, 0, minus X plus X plus X. 0.175 minus X, but X is negligible when we're dealing with weak acids. X, X. Here we go. They want us to calculate the pH in C. So we got to get X first. So 3.2 times 10 to the minus 8 is equal to X squared over 0.175. So X is going to be equal to the square root of 0.175 multiplied by 3.2 times 10 to the minus 8. Negative log of X gives us our answer. I do apologize that I'm not doing these. YouTube only lets me set up 10-minute videos, and if I have to do the calculations for each one, I don't have those on me. Actually, I do have a solution set, but I don't have them near me right now, so I'm just setting up these calculations. It's really what's most important. You want to think about your answer should be less than 7, okay? Not less than 1, but less than 7 because it's acidic. Okay. D, calculate the free energy change. Here we go. D delta G equals negative RT ln of K. G equals negative 8.31 times the temperature, STP, 273 natural log of K. And I believe they did give that to me, 3.2, it's right there, times 10 to the minus 8. Okay, delta G should be greater than 0 in this case, which makes it non-spontaneous. Okay, that was D. Let's solve for E, which asks for the net ion equation when these two things react with a strong base. So if HOCl is a strong base, it's not separated or weak acid, it's not separated with water, but Na plus OH minus should be separated with water. I do see ions. So I'm going to connect and cancel. Na is an alkali metal, so it's going to be broken up in water, and I have H2O here. Na is my spectator ion, so I'm going to rewrite it, and I'm going to get this. And they want me to draw the titration curve when HOCl is titrated. I'm actually going to write Na plus OH minus here because that's the strong base that we're dealing with. As we add base, pH goes up, it buffers out because it's a weak acid, and we have our place. pH is greater than 7 here. We get the buffer zone where the pH equals the pK. This is the BZ, the buffer zone. Alright, great problem for you guys to go over. Problem 7. I'm going to do my ice chart. HF aqueous plus H2O liquid goes to H3O plus, which is the same thing as H plus. To draw that water in there, sometimes H3O plus is another way of writing H plus and H2O mixed together. But the important thing is that it's aqueous. ICE, don't count liquid. Ka is equal to F minus multiplied by H3O plus divided by HF, because we do not count the liquid, which is equal to 7.2 times 10 to the negative fourth. They gave that to me right there. Here we go. Ooh, am I losing power? No. Okay. Okay. Alright. Sorry. Okay. So here we go. We're going to solve this problem. When we look at it, they want the equilibrium constant expression. There's A, we got that. Calculate the molar concentration of H3O plus, same thing as H plus, in a 0.40 molar HF. So this is 0.40, 0. This is minus X, 0.40, plus X, X, X. So they're just asking for this, that's it. So they're asking us to solve for X. So 7.2 times 10 to the negative fourth multiplied by 0.40, square root of that equals X, which equals the concentration of H plus right there. Calculate the pH and the pOH. Alright, great problem. This is answer to B. C, well, we know this relationship, pH plus pOH equals 14. So the negative log of X, whatever you got from right there, plus pOH equals 14. So 14 minus the negative log of X from there equals pOH. Alright, moving on to the next problem, guys. Alright. Problem number 1 from multiple choice. Practice test number 1. MC20. So they give us a weak acid, HA, and it breaks apart into A minus. So anytime you see K, always set this up. ICE, they tell you, you know, A minus multiplied by H plus over HA is Ka, and they give you Ka, which is 2.5 times 10 to the negative 6. Okay, and they ask you for the pH, and they tell you this is 0.400 minus X, 0.40 plus X, X. So X squared divided by 0.40 equals 2.5 times 10 to the negative 6. So the negative log of the square root of 2.5 times 10 to the negative 6 multiplied by 0.40 equals the pH of the solution. Now this is a weak acid, so it's not going to be 8. I believe the answer is C, but it should be something less than 7. Not quite sure yet. Do out that calculation and you should get it, but this is exactly how you do it. I'm going to stop right here, guys, and one more vodcast and we should have all these problems done.